Hi grade 10s and welcome to this video. In this video we will be working on the Mathematics Paper 2 for June 2025, and this is specifically from the Gauteng province. Question 1.1 says, from the diagram below we have A, which is -4 and -2, and B, 3 and 5 are given. Determine the following. Of course, they also give us these other 2 points. So they want us to find the gradient of AB. Okay, so we've got A and B. We can just take this as point number 1 and point number 2. And so to find the gradient of a line, the formula is the change in y over the change in x. So we have already marked our first and second point. And so we're going to take y2, so the y value of point number 2, which is 5. So this is 5 minus y1, which is -2, so minus -2, all over x2 minus x1, which is 3 minus -4. So 3 minus -4, and this will give us the gradient of AB. Okay, so finally, gradient of AB is equal to, when we multiply negatives, they become positive. Okay, negative times negative is a positive, so that's going to be 5 plus 2, which is 7, and then 3 plus 4, which is also 7. So this is 7 over 7, which gives us 1, and that is the gradient of line AB. Moving on to the next question. Question 1.1.2 asks for the length of AB. Okay, we already marked these points, so we just need the distance formula to find the length. So this is x2 minus x1 all squared plus y2 minus y1 all squared. And so this distance is equal to, and we say the square root of, these points have already been named. So x2 minus x1, that is 3 minus -4. So 3 minus -4 all squared plus, and then of course the 5 minus -2. Okay, just like we had with the gradient. So 5 minus -2 all squared, and let's find the distance of AB. We can just go ahead and call that AB. And AB is equal to, and we have 7 root 2, but then of course that's a decimal, and we'll round off to 2 decimal places. So AB is equal to, that third 9 is going to round that 9 up to a 1, so that carries over to the 8, and so this is just going to be 9.9, okay, because it carries over. Okay, so we can just leave it as 9.9, and that is our answer. Moving on to the next question. And then 1.3 asks for the midpoint of AB, again using AB. So midpoint, remember, is x1 plus x2 over 2 and y1 plus y2 over 2. So the midpoint of AB, let's just take those x and y values. We can, of course, just look at the diagram itself. So that is -4 plus 3 over 2, -4 plus 3 divided by 2. And then the y's, that's -2 plus 5 over 2. So -2 plus 5 over 2. And finally, the midpoint of AB is 3 minus 4 is -1 over 2 is just -1 over 2. And then 5 minus 2 is 3. So 3 over 2. So 3 over 2. And that is our answer. Moving on to the next question. The next question, question 1.2, we can see this is on trigonometry. So 1.2 says, use the diagram below with point A. So this is point A, -3 and -4 to answer the following questions. Okay, so they want us to find the value of R. So they've given us this point A, and you can see they gave us an X and a Y value. So we'll draw a line from this point to the x-axis, and this line is of course going to be perpendicular to the x-axis. Now, when looking at this point, -3 and -4, to plot it, you would go 3 units to the left and then 4 units down. So that -3 goes here, and the -4 goes here. And now we have to use this info to find the value of R. So this is a right angle triangle, meaning we can use Pythagoras to find R, the hypotenuse. So it's the hypotenuse, so R squared would be equal to the shortest side squared plus the other shortest side squared. And we'll say R squared is equal to, and that's just going to be 9 plus 16, which is 25, and then square root both hand sides of the equation. Yes, we have to consider the positive and the negative solution, okay? But remember that r is a length, so it's just going to be positive. So r is equal to 5. And the reason you consider the positive and negative is because r squared is equal to 25 is an equation. And you're asking yourself, what squared gives you 25? Well, 5 squared is equal to 25, but negative 5 squared is also equal to 25. So both answers should be considered, but then make your decision based on what you're trying to find. And that is our answer. Moving on to the next question. Question 1.2.2 says calculate the value of cos theta and tan theta. So to find the value of cos theta, we can use this acronym, so SOHCAHTOA, to find these sides. So cos is adjacent over hypotenuse. So cos equals adjacent over hypotenuse. So we're going to go ahead and find this. So let's look for cos theta. And I'm starting to realize that this theta has been drawn in the wrong place. It shouldn't be here. It would not stand for the theta they're clearly intending it to be. So that shouldn't be here. Okay. It should be, they could have at least, well, they could have shown that it was measured like that. Okay. And then theta. And then when you get to grade 11 and you learn about reductions, you will see that theta can be reduced to this angle over here and will still hold the same value. So like cos theta will still hold the same value. Okay, so cos theta. Remember from SOHCAHTOA that cos is adjacent over hypotenuse. So we'll take the adjacent side. So opposite is negative 4, but next to the angle is negative 3. Okay, so this is the adjacent side and then over the hypotenuse, which is r, and we already found that. Okay, we found that to be 5 units, and I'm just going to rewrite it there. That is 5 units. Okay, so we can go ahead and say it's the adjacent side of negative 3 over 5. And then tan theta. Tan is opposite over adjacent. So opposite is negative 4, and the adjacent side is negative 3. So that is negative 4 over negative 3, which simplifies to 4 over 3, and these are our answers. Moving on to the next question. And then the final question, 1.2.3, says we need to prove that cos theta multiplied by tan theta then times sec theta is equal to 4 over 3. Okay, so we know cos theta and tan theta. I'll just rewrite it first. Okay, so they want you to prove. So when you multiply these, they give you 4 over 3. So we're just trying to multiply these. We know the values of these. Okay, so cos theta, that is negative 3 over 5. Tan theta is 4 over 3. And then let's find sec theta. Okay, so remember that secant theta is equal to 1 over cos theta. So if cos theta, we would find cos theta by saying the adjacent side over the hypotenuse. Then when you say 1 divided by a value, okay, we're saying 1 divided by cos theta, which we know is adjacent over hypotenuse. When you're dividing by a fraction, you can use tip and times to simplify this further. So we would leave the 1 exactly the same, and then we tip this fraction, meaning swap the numerator and denominator. So it's now h over a. And then change the division to a multiplication. So this is just h over a. Okay, so that's what that becomes. It just swaps. So if cos theta equals a over h, then secant theta is h over a. Okay, so let's just go ahead and find that in our diagram. So h over a. And so we'll say the hypotenuse over the adjacent side. So the adjacent side is the side next to this angle. So that side is negative 3. So we're just going to say 5 over negative 3. Okay, so multiplied by, they're all multiplying, by 5 over negative 3. And then you can multiply them by yourself or use a calculator, but you can just multiply normally here. So it's negative, we have a negative and a negative, so they become positive. And I see that I can just cancel out the negative 3 and negative 3. They cancel diagonally because they're common. And then there's a 5 and a 5. They would also cancel diagonally. So those are gone. And then all we have is 4 over 3. So if you use a calculator, you'd also see it simplifies to 4 over 3. And there we go. We have proven this. And that is it for that question. And that is it for question 1. Question 2.1 says, determine the values of the following using a calculator. So all you have to do is punch this into your calculator and get the answer. Okay, so let's go ahead and do that. So on your calculator, you're going to put a fraction on saying 3 cos 120 degrees all over sine 150 and then minus cos 80. Okay, 3 marks. So we say this is equal to negative 4 point and just round off. So that 6 is going to round the 9 and that will carry that 1 over to the 5, which becomes a 6. So it's negative 4.6 and you can leave it like that, or if you have to round off to 2 decimal places, you can leave it as negative 4.60, okay, and that is fine. Moving on to the next question. The next question says 2.2, determine the value of each of the following equations correct to 2 decimal places. So 2.2.1, we have 4 sine theta is equal to 2.1. Okay, so you just have to find the value of theta. Okay, so we need to solve for theta. And right now, we still have sine in front of theta. So you need to isolate sine theta. And we can do that by getting rid of the 4. The 4 is multiplying to sine theta. So to get rid of it, you divide by 4. But this is an equation, so you need to divide on both hand sides. So this is currently sine theta equals, and you can't find that in decimal form, but I'll just leave it as 2.1 over 4 for now. And now finally we can find the value of theta. Okay, they didn't really specify that theta is greater than 0 degrees but less than 90 degrees, but they probably mean this. So we're just going to solve for this. Anyways, that's the only way that you solve for trig equations in grade 10. In grade 11, it's a little different. So we can go ahead and transpose the sign. And so theta equals, we're just taking that over to remove it. And when we do that, it's going to become the second function of sine. Okay, so on your calculator, you activate that by pressing shift and then sine and then input your value. So it's 2.1 all over 4. And so that is our answer. Our answer is 31 point, and to 2 decimal places, the 8 will round that 6 up to a 7. So it's 67 degrees. And that is our answer. Moving on to the next question. The next question, we have another equation where we need to solve for theta. So the whole point is isolate theta. Right now, what is in the way, it's not really the 15 degrees yet, it's the cos. Okay, we need to get rid of this before we can even touch the 15 degrees. So transpose, and we have theta plus 15 degrees. And on our calculator, when that comes over, it's going to become the second function of cos. So we press shift and cos, and we apply it to this number that we have here. So that's 0.845, and that gives us 32 point. Now at this point, I'm going to round off. And the reason why is because even when we take this 15 over, because it's a whole number, it's not going to affect your decimals. So it's fine to round off at this point. So the 8 will round that 2 up to a 3. So we have 32.33 degrees. And then we can finally isolate theta. So theta is equal to transpose, and we have 32.33 minus 15 degrees. And so that gives us 17.33 degrees, and that is our answer. Moving on to the next question. The next question, 2.3, says, without the use of a calculator, determine the value of, we have this, and you can see they're using some special angles here. Okay, so if you wanted to ensure that you did not use a calculator at all, we can use this method. You can use your triangles, your special triangles, the circle. Okay, this is a circle method of doing this, but I'm going to use a rule called the OHA rule here. So with the OHA rule, you have to use this with the acronym SOHCAHTOA. Okay, and we're going to say OHA, so OHA, and that stands for opposite, hypotenuse, and adjacent. And then we're going to put down our angles here. So it's going to go in this order. It's 30 degrees, 60 degrees, 45 degrees. And then we put down our numbers here. And that's going to be 1, 2, 3, 3, 2, 1, and 1, 2, 1. Then in each row, square root the biggest number. So here it's the 3, here it's the 3, and here it's the 2. And there we go. So when we see sine 0 degrees, these are one of those angles where even if you use a calculator, it's fine. Okay, These ones, however, sometimes they are different. It's mostly 45 degrees that you have to actually just use the rule, because if you use the calculator, they would know. Okay, so if you say sine 0 degrees, you can use your calculator, but I know that sine 0 degrees is 0, and then plus cos squared 60 degrees. We would need to find cos 60 degrees first, and then say that is squared. So cos 60 degrees, cos, remember using SOHCAHTOA, cos is the adjacent over the hypotenuse side. So because we're working with 60 degrees, we'll go to our 60 degrees row, okay? And we're going to say adjacent over hypotenuse since we're working with cos. So adjacent is 1 over the hypotenuse, which is 2. And so this is actually 1 over 2 squared. And then plus, we have the square root of 2. And you see it's next to cos 45 degrees, so they are multiplying. And then cos 45 degrees, we know cos is adjacent over hypotenuse. So we go to the 45 degree row, and we're going to take the adjacent side, which is 1, over the hypotenuse, which is square root 2. So that is 1 over root 2. And this would be strictly without using a calculator. Okay, so this is equal to, and let's just go ahead and simplify this. So just focus on the amount of terms that you have here. Terms are always separated by plus or minus signs. So here's a plus sign. Okay, here's another plus sign. And so what this means is there are 1, 2, 3 terms. And we'll simplify this expression term by term. 0 is just 0, and you don't have to rewrite it, okay? And then we go to a half squared, square that, and it becomes 1 over 4. And then deal with this. So these are multiplying. But do you see that in the numerator we have root 2 and in the denominator root 2? So they would cancel. And so that simply just becomes 1. Okay, so plus 1. And so what is a quarter plus 1? Just multiply the denominator with a whole number, that's still 4, and then add that numerator. So this is 5, and then the denominator stays exactly the same, over 4. And there we go. Okay, so that is our final answer. Moving on to the next question. The last question for question 2 says, find the value of x without the use of a calculator. Okay, so x is over here. So to get x alone, do you see that all we have to do is get rid of this? Okay, so we'll have to simplify these further as well. So we can leave this as x. And then what is cotan 60 degrees? Well, this is the reciprocal for tan. And so it is 1 over tan 60 degrees. Okay, that's what it's equal to. And so remember that tan is opposite over adjacent. So that would mean that cotan is going to be adjacent over opposite. It's the reciprocal. So the numerator and denominator switch places. And so here's where this is going to be useful. We can keep using the OHA rule since we can see they are using special angles here. There are some exceptions and we will work on that as well. But we can see that cotan 60 degrees is adjacent over opposite. So go to 60 degrees and take the adjacent over the opposite, which is 1 over root 3. Okay, so this is x multiplied by 1 over the square root of 3. And this is equal to, and we continue, and what do we have here? We have sine 50 degrees. And then we have sine 50 degrees. So sine 50 degrees multiplied by, now I'm not doing anything to this because 50 degrees is not a special angle. So the minute you see something like that, then it means that they can probably simplify by cancelling. We just have to find out what exactly that is. Okay, then we have sine 30 degrees, and sine 30 degrees, we know that sine is opposite over hypotenuse, so sine 30 degrees is 1 over 2. So it's multiplied by a half, and then it's multiplied by cosec 50 degrees. And we know that cosec, okay, 50 degrees is equal to 1 over sine 50 degrees. So that makes sense now. That's why this is here. So you could leave it as 1 over sine 50 degrees, just so that you can see how these ones would cancel. So then we put this all over and we have cotan 45 degrees. Remember that tan 45 degrees, or tan really is just opposite over adjacent, okay, TOA. And so cotan would be adjacent over opposite. So go to the 45 degree row in your OHA rule, and we're just going to take the adjacent over the opposite. So the adjacent is 1 over the opposite, which is still 1. Okay, so tan 45 degrees is 1, cosine 45 degrees is also 1. Okay, so that's all over 1. And so this is equal to, we can go ahead and get rid of this now. Now to get rid of it, you can either decide to divide both hand sides by 1 over root 3, or you could simply multiply both hand sides by its reciprocal. So instead of 1 over root 3, you would multiply both hand sides by root 3 over 1, or really just root 3. Because that way, the numerator here would cancel with that denominator since they are common. But what you do on one side, you must do on the other side. So here, we also multiply all of this by root 3. And now we have x alone, okay? And so let's just see what happens inside. You see here, you have a sine 50 degrees. And then it's going to multiply by this 1 over sine 50 degrees. What happens when you have the same thing in the numerator and the denominator and you're multiplying? They would cancel because they're common factors, okay? So if we had to multiply them normally, we would say numerator times numerator and this natural denominator of 1 times this denominator. And you see how it's the exact same thing over the exact same thing, and that's why they cancel and simplify to 1. Okay, so those cancel and they're gone. And so all we have in the numerator is this 1 over 2 multiplied by the square root of 3. And so finally, this means that x is equal to numerator times numerator, root 3 all over 2. And that is our answer. Okay, so that is it for that question. And that is it for question 2. Question 3.1 says, in the diagram below, angle A is equal to 40 degrees, angle C2 is equal to 100 degrees, and BC is equal to CD. Okay, so let's just put that down. This is equal to this. So they want us to determine with reasons the sizes of the following angles. We have angle B1. Okay, so the only thing we are told so far is we have these two lines being equal, meaning this is an isosceles triangle. But they want us to use this now with everything else to find angle B1. Okay, do you see that angle B1 is part of this triangle that we have here, right? And this triangle, there's two ways to find angle B1. You can either choose to, this is for 2 marks though, but you can either choose to find angle C1 and then use the sum of angles in a triangle and find angle B1, which is a 2-step process. Or you could have just done this instead. You could have seen that we have an exterior angle over here, which is 100 degrees. And we know that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. And that's how we can find it. So we know that if we say angle B1 plus 40 degrees, it will give us that 100 degrees. And we could put our reason down. Okay, exterior angle of a triangle. And so finally, angle B1 equals, you would transpose the 40 degrees. And so 100 degrees minus 40 degrees is 60 degrees. And that is our answer. Moving on to the next question. Also, just make sure to put down whatever you have found. We know that this is now 60 degrees. Okay, next question. The next question, 3.1.2, we need to find the size of angle B2. Okay, so angle B2 is over here. And so how do we find angle B2? So how we would find angle B2, you can look at the triangle that angle B2 is a part of. This triangle. What were we told about this triangle? That BC is equal to CD. So we have an isosceles triangle. So when we have an isosceles triangle, you see these sides that are equal. The angles opposite these equal sides would also be equal. So that would mean that, you see, this is CD. It means that this angle, angle B2, and this is BC, okay? That angle, angle D1, would be equal. Okay, so these two angles are equal. And we can just go ahead and state that. So we can tell them that we know that because they told us that BC was equal to CD, and I'll state that down first. BC is equal to CD. Not really necessary, but I'll still tell them. And our reason here is that this has been given. We didn't find this. They told us this. And so because of this, we can finally conclude that angle B2 is actually equal to angle D1. So angle D1. And the reason we give is not isosceles triangle, but rather angles opposite equal sides are equal. As we saw, the angles that lie right opposite these equal sides are also equal to each other. Okay, we can also just leave that as angles opposite equal sides. So here's the thing. Because these two are equal, we can use the sum of interior angles in this triangle. And so we'll say angle B2 plus angle D1, but since angle D1 is equal to angle B2, we can call that angle B2 as well. And that would leave angle B2 as our variable in our equation, and then we can solve for it. Okay, so we're just saying angle B2 plus angle D1, and then plus that third angle, which is angle C2, which is 100 degrees, that they would add up to 180 degrees. And this is because of the sum of interior angles in a triangle. Okay, and so finally we can conclude that angle B2, and then in place of angle D1, because they are equal, I replace that with angle B2, and plus 100 degrees, or we might as well just transpose now, so is equal to 180 degrees, and when this comes over, it becomes negative 100 degrees. And so finally, when we add these two together, this is 2 angle B2, okay? Just like x plus x is 2x, so angle B2 plus angle B2 is 2 angle B2, is equal to, and that gives us 80 degrees. And finally, to solve for angle B2, we divide both hand sides by 2, and angle B2 is equal to 40 degrees, and that is our answer. Okay, so we can also put that down. We can tell them this is 40 degrees, and because those two are equal, this is also 40 degrees. Moving on to the next question. Question 3.2 says, give two properties of a rhombus. Okay, so just give any two properties of a rhombus that you know. So if a shape is a rhombus, one thing we know about it is that all the sides are equal. Okay, another thing we know about it is that the opposite sides, or really both pairs of opposite sides, are parallel. So this is parallel to this, and this is parallel to this. So I'll just list those down. Okay, so there we go. Moving on to the next question. Question 3.3 says, the diagram below shows parallelogram ABCD. Okay, so this parallelogram with AB being parallel to CD and AD being parallel to BC. So this shape would hold all the properties of a parallelogram, which you need to make sure to study so that you can actually work with it. So they tell us that angle A is equal to x plus 20 degrees and angle C is equal to 2x minus 60 degrees, and determine the value of angle C. So ultimately, we need to find the size of angle C. But do you see that in order to do that, we would need the value of x? Because if we can find out what x is, then we know it's 2 times whatever this is, minus 60 degrees, and that is the size of angle C. So how would we find x? There's an equation that we can create from this because of the properties of a parallelogram. So amongst the other properties that we have, you know, opposite sides are equal, so this is equal to this, and that's equal to that, and opposite sides are parallel, as we can see as well. You should also keep in mind that in a parallelogram, the opposite angles are equal. So that's where our equation would come in. So angle A would be equal to angle C, and we'll put down our reason. Okay, so the opposite angles in a parallelogram are equal. So therefore, this means that x plus 20 degrees is equal to 2x minus 60 degrees, and we can just solve for this equation. Okay, so we need the x's on one side and the angles on one side. So leave x here, and we're going to transpose the 2x, and becomes negative 2x is equal to, and we have negative 60 degrees here, and we're going to transpose the positive 20 degrees, which becomes negative 20 degrees. So x minus 2x is negative x is equal to, and negative 60 minus 20 is negative 80 degrees. And then just get rid of the negative, either by dividing by negative 1 on both sides or multiplying by negative 1. You can also do that. So finally, x is equal to, and we have 80 degrees. And we know what x is now. Remember, the goal is to find angle C. So angle C, as we can see, is equal to 2x minus 60 degrees. But we know what x is now. So angle C is equal to 2 and then times 80 degrees and minus 60 degrees. Okay, 2 times 80 degrees 160 degrees, and then minus 60 degrees is 100 degrees. So angle C is equal to 100 degrees. And that is our answer. Moving on to the next question. Question 3.4 says, in quadrilateral ABCD, we have AD being parallel to BC and angle B is equal to angle D. So this angle is equal to this angle. We need to prove that ABCD is a parallelogram. Okay, so there are various ways to prove that a shape is a parallelogram. There's really 5 ways, and I'm going to put them down so that we can decide based on our diagram which one we're going to focus on. Okay, so these are the 5 ways we can prove that a shape is a parallelogram. Okay, a quadrilateral is a parallelogram. So with this, let's just think about what we could do here. We could either decide to go with both pair of opposite sides are equal. And so that would mean that you would have to prove that this side is equal to this side, okay? And then this side is equal to this side, which we can do, okay? All of these things, they are actually quite simple to do once you get the main thing that just needs to be done for this to be true. And then the second case, we could look at both pair of opposite sides being parallel, okay? We already have one being parallel. You know, this, if we can prove that those are also parallel, then that is it. So we could also just go with that as well. We can also prove that both pair of opposite angles are equal because in a parallelogram, like we saw in the previous question, the opposite angles are going to be equal. And so this would be equal to this. We could go for that. And then one pair of opposite sides are both equal and parallel. That's also another nice one to go for because we already have these being parallel. So if we could just prove that they are equal, and we're done as well. And then the last one is that the diagonals bisect each other. I would not go for this because we only have one diagonal here. We don't have any coordinates. We can't actually show that the diagonals bisect each other. To show that diagonals bisect each other, all you have to do is show that they have a common midpoint. Because if this is the middle, then it means that this is equal to this, and this is equal to this. In that way, this diagonal is cutting that one into 2 equal parts, and this diagonal is cutting that one into 2 equal parts. So I would actually go for the one where I don't have to focus on finding 2 things. I just have to focus on concluding one thing. So maybe go for this one. Both pair of opposite sides are parallel, okay? You could also go for this one. Both pair of opposite angles are equal since you already have one pair being equal. So just find that the other pair is equal and then you're done. And we could also go for this one. One pair of opposite sides are equal and parallel since these are already parallel. So if you can just show that they are equal and we are done. Okay, I'm going to go for this one. One pair of opposite sides are equal and parallel. But regardless of the one that you go for, we are still going to use the same approach. So since I'm going for that, what I want to prove right now is that AD is actually equal to BC. And here's where we will still all use the same road, okay? To do this, we would have to focus on these triangles individually. You see how these triangles look very similar, okay? In fact, they look identical. It looks like this one was just flipped over and then put on there. And that's because it actually is. We just have to show them this. And this is how we would do this. We would prove that these 2 triangles are congruent. And congruent triangles are equal. All their corresponding sides and angles are exactly the same, meaning you can literally take this triangle, flip it over, and it will perfectly lie on that triangle because they are really the exact same triangle in length and angles, okay? All of those are exactly the same. Okay, so let's go ahead and start introducing our triangles to prove that they are congruent. So in triangle ABC, now the way it's named is also important. I'll just try to name it properly, it's fine. Just try to name it properly just so that you have presented it correctly. So ABC, so I will call this one CDA, okay? So A, B to C, okay, so the blue one, and then it's from C to D to that, passing that blue marker. Okay, so in triangle ABC and triangle CDA, let's go ahead and prove this. So if you can prove any of the 4 cases of congruency, then your triangles are congruent. So what do you notice? I need to take that out. They're not equal yet. What do you notice are equal in your triangles? We were first already given that angle B was equal to angle D. So we'll go ahead and state that. Angle B equals angle D, and this is a given angle. We didn't have to find it, it was already given. And then what else is equal? Do you see how AC is a shared side? So we can tell them that AC is equal to AC because this is a shared, or you can say common, side. Okay, so we've got an angle, we've got a side. What else? Now you see that we have parallel lines. When we have parallel lines, this helps to create fun angles. Okay, so fun angles are the F for corresponding angles. So if these are parallel, this angle is equal to this angle. And also alternate angles, which can be seen as a Z if these are the parallel lines, or a Z this way. Okay, and those are the parallel lines, so this is equal to this. And we can see that here. Okay, so we have alternate angles. So angle A2 is equal to angle C1. Okay, so we can go ahead and tell them that. I'll start with angle C1 because it's in this triangle. So angle C1 equals angle A2 because we have alternate angles. And I'll just put that down. This is equal to that. Okay, and we can just tell them these are alt angles and just tell them the lines that are parallel. We know that AD is parallel to BC. And there we go. We have three things being equal: an angle, a side, and an angle. So finally, this means that triangle ABC is indeed congruent to triangle CDA because we have angle, side, angle. Okay, so there we go. Now that they are congruent, all their other corresponding sides and angles are equal. Okay, so if you look at these triangles, I'll just get a crop of this part. Okay, so here we are. If you take this part of the triangle and you flip it over, look at exactly how it looks. Do you see how it fits perfectly onto this and they look exactly the same? They have the same equal angles. That angle is equal to that angle, that is equal to that. And so therefore all the other corresponding sides and angles would also be equal. So that would mean this side is equal to this side, and this side is equal to this side. Okay, that AD is equal to BC. And then of course this AC was already equal. Okay, so that's what I mean by we're still going to use the same journey, proving they are congruent, and then you can go whichever route you want to go, using any of the 5 ways that you prove that a shape is a parallelogram. Okay, so I'm more focused on showing them that AD is equal to BC because I can see they are equal. Okay, all the corresponding sides and angles are equal. So finally, I'm going to conclude, therefore, because they are congruent, I know that AD is actually equal to BC. So remember, we're just trying to prove that this is a parallelogram. So ABCD finally is a parallelogram. And the reason it is a parallelogram is because we have one pair of opposite sides being both equal and parallel. And there we go. Okay, and there we go. And that is it for that question. And that's how we prove that. Moving on to the next question. Question 3.5 says, if quadrilateral ABCD is a parallelogram and we have AD is parallel to BC and AB is parallel to CD, and they also give us that angle A is equal to 100 degrees and CD is equal to DE. Okay, so you see we have an isosceles triangle here. There are 2 angles that would be equal. If angle D2 is equal to 2x, then calculate the value of x. Okay, so the whole point is to just find x. So you need to find a way to create an equation, okay, using the properties of, parallelogram or even this triangle that we have here. And that equation should help you solve for x. Okay, so let's go. So we could do this. X is over here. And the way we can form an equation with x could be I was thinking of using the exterior angle, which could be helpful. Because if this is a parallelogram, the opposite angles are equal. So this would also be 100 degrees. And then we could just use the exterior angle of a triangle. But I don't really see a use because I'm trying to avoid finding another angle and then jump into another angle. But it seems like we can't really avoid this, and that's fine. So we can simply find this angle and tell them, yes, this is really equal to 100 degrees. So angle C1 equals 100 degrees because we know the opposite angles in a parallelogram are equal. Okay, opposite angles in a parallelogram, I'll just call it a palm, are equal. And then we can do this. We can focus on finding angle C2. Because if we find angle C2, then you know that these two lines are equal. Therefore, the angles opposite their sides are also equal. So this angle would be equal to this angle. Okay, so let's find angle C2. So we know that if this is 100 degrees, then we know the angles on a straight line add up to 180 degrees. So angle C2 plus 100 degrees would give us 180 degrees, and this is because of the sum of angles on a straight line. And then we'd find angle C2. So angle C2 is equal to 180 degrees minus 100 degrees, which is 80 degrees. And so we know that now. This is 80 degrees. And they gave us that these two were already equal. So I'm just going to state them down first. To tell them that I know that CD equals DE. So CD equals DE. And this has already been given. And so because they are equal, it means that angle C2 is equal to angle E. Okay, those two angles are equal. So angle E is equal to angle C2. Therefore, angle E is equal to 80 degrees as well. And the reason for them being equal is because the angles opposite the equal sides are equal. Okay, so now we can finally just go ahead and use what we have here to create an equation to solve for x. So this is 80 degrees. Do you see that we have a triangle? And we know that the sum of angles in a triangle add up to 180 degrees. So that means if we take 2x plus the 80 degrees and the 80 degrees, they will add up to 180 degrees because of the sum of angles in a triangle. So finally, 2x, and then we add 80 and 80, that's 160. Okay, so we have plus 160 degrees is equal to 180 degrees, but then we would transpose 160 degrees, so it would become negative. So we have 180 degrees still here, then minus 160 degrees. So 2x is equal to, and that gives us 20 degrees. And then finally solve for x by dividing both hand sides by 2, and x is finally equal to 10 degrees. And that is our answer. And that is it for question 3.5. And that is it for question 3. Okay, so that is the last question for this paper. And that is it for this paper. I hope you guys enjoyed it. If you do have any questions, you can leave them down in the comment section below. And I will see you guys in the future videos.